Alright guys, today we're going to look at 7G, which is models of polynomials. One thing to know about this target is this whole target on the test is going to be non-calculator. So this whole time you are not allowed to use a calculator. So let's look at example 1. Write a polynomial function in standard form with the following zeros. My zeros are -1, 3/2, and 4. The first thing I want to do is take this 0 and take these zeros and write them as factors. When I write them as factors, I change the sign. So that's x plus 1. Fractions are a little different. Fractions, you slide the 2 over. Right, so whatever's on the bottom, I'm going to slide it over to 2x and then change the sign. So 2x minus 3. And then I have x minus 4. The last thing I need to do, just like we did before, is multiply. Okay, so here I'm just going to distribute. I'm going to ignore my x minus 4 to start, right? So I'm not going to use that one first. I'm just going to distribute x times 2x, which is 2x squared, and x times -3 minus 3x. Then 1 times 2x, which is 2x, and 1 times -3, which is -3. Simplifying this by combining like terms, I get 2x squared minus x minus 3. Now I'm going to add back in the x minus 4. Right. Multiplying again, 2x squared times x is 2x cubed. 2x squared times -4 is minus 8x squared. Negative x times x is minus x squared. Negative x times -4 is plus 4x. Negative 3 times x is negative 3x. Negative 3 times -4 is plus 12. Again, after that, I just have to simplify. 2x cubed minus 9x squared plus x plus 12. There is my solution. All right, let's look at B. Same type of thing for B. All right, my first factor is changing the sign, x minus 2. Then I have a fraction. Again, with a fraction, I need to slide the bottom number over. So 5x minus 1. Again, it's minus, so I change the sign. And then by -3, changing the sign is x plus 3. I'm going to start by, and I'm just distributing. X times 5x is 5x squared. X times -1 is minus x. -2 times 5 is minus 10 x. And -2 times -1 is plus 2. And then before I multiply, I want to simplify this. So I get 5x squared minus 11x plus 2 all times x plus 3. Now distributing again. 5x squared times x is 5x cubed. 5x squared times 3 is plus 15x squared. Moving to my next term, -11x times x is minus 11x squared. -11x times 3 is minus 33x. 2 times x is plus 2x. And 2 times 3 is plus 6. And then again, just simplifying. I get 5x cubed plus 4x squared minus 31x plus 6. And that is my answer. So this part is very similar to what we did in target C. Right? Then looking at example 2. Example 2 says, create a rough sketch of the function with the following key features. I want my real zeros at x equals -3, 0, and -4. And I want the end behavior where as x is approaching negative infinity, it's going to infinity. And as x approaches infinity, it goes to negative infinity. So what I'm going to do here is I'm going to start with my zeros. I have a 0 at negative 3, at 0, and at negative 4. So those are my x-intercepts. Then, looking at my end behavior, on the left side, it goes down. Or sorry, it goes up towards infinity. So at my farthest left point, I'm going to put an arrow going up above it. On my right side, as x approaches infinity, it's going down. So at my farthest right 0 underneath it, I'm going to put an arrow going down. So the last thing I have to do is just connect the dots. Alright, starting at this arrow, I'm going to go through here. You have to go through the point. At some point I have to turn to get through here. I have to turn again, and I'm ending up going down. Okay, this is my rough sketch. I don't know how high up or down these go, but I know that this is approximately what it's going to look like. All right, looking at example 5, create a rough sketch of this function, right? Negative 5, negative 2, negative 1, and 1 are my zeros. I'm going to put a 0 at negative 5. I'm going to put a 0 at negative 2, negative 1, and positive 1. Then my left side is going down. My right side is going down. And then I'm just connecting my dots. So this one kind of looks like an M. Okay. And that's it for this first part of Target 7B. We'll work on that part tomorrow. Okay? I will see you guys tomorrow. Have a wonderful rest of your day.